This question, we will be looking at the forces acting on this big tanker, and we also will be practicing how to sketch a displacement time graph. So first, let's analyze the question together. So here we have a tanker, and they actually tell you that it moves from rest and that it is traveling in a straight line. So it limits the dimension of our motion if it is just forward, backward. Okay, so it makes it easier. The mass is given, so my habit is that once the mass is given, it will be easier for me to extract data if I write down the numbers in the diagram. So I write over here. Then after that, it says that there is a force that is acting on the tanker due to the propeller. So down here, you can see that they say there's a forward force with a fixed value. So I will just draw it over here. Okay, there's a fixed force. This is F. It's not F net, it's just F. F is just a force. Okay, it's not F net, it's different. So I have F, which is 2.5 times 10 to the power 5. Yeah. And then it says that the acceleration is not constant. So now once you have this hint, you will know that there must be some other forces acting on it, because if the forward force is a constant value, then you would expect the acceleration to be constant. But now, because the acceleration is not constant, it means that very likely there is another force. So when you have a ship moving through liquid or in air, I think most likely there will be a certain drag force over here. It can be, it is called a resistive force or drag force. It comes with many names, but essentially it is just some forces that resist the motion of the object. So I will just call it R in general. So this force R is like your air resistance. I think it will definitely change with speed. So it is a changing force. So if you create this mental picture in your head, then very likely you will be able to see that your F net consists of two forces, F, which is the forward force, plus the negative R. So since your F net is given by the second law, M times A, the right hand side is F minus R. Since this force is changing, then very likely that this will result in your acceleration being not constant. So just from these two lines, I can extract this much of data. Okay, now we look at the second paragraph. Okay, the second paragraph basically tells you the motion of this tanker ship. So down here it says that the engine stopped. So the implication of this is that this particular force will no longer be there, but because the tanker is already moving, there will be still resistive force acting on the tanker. So it means that this resistive force will definitely slow down the tanker. So as you can see here, the velocity of the tanker decreases. So that is because the drag forces are still acting on the tanker. Then after that, the question says that after another 40 minutes, the tanker is actually still traveling forward at 12 kilometers. So even though that the resistive force is the only force acting on the tanker, it doesn't mean that the tanker will actually reverse and go the other way. So this is similar to the bus slowing itself down while it approaches to the bus stop, right? So it slows down, but it is still going forward. Okay, so if I want to see this data clearly, what I can do is that I can put them in a table form. So I will put time here. So I will take time equals to 0 when the engine stops. Then after that, I will write down, okay, I want to study the velocity, and then I want to study the distance traveled. So when the engine stops, I will take that as my reference point. That is when my distance is 0. Okay, I do not know what is my starting velocity because it is not stated, so I will just put V, a dummy alphabet. Then after that, I will just use the data given in the question. It says after 40 minutes, right? So I will just write, okay, after 40 minutes, what happened is that my velocity will decrease. So I just put V and a downward arrow to tell myself that, okay, it is slowing down. So for some of you who are still not very familiar with the concept of velocity, what you can do is that you can just write down the word slow in your table, slow down. And within this 40 minutes, it actually traveled forward 12 kilometers. Yeah. Then after that, it says here, at the end of this 40 minutes, the velocity of the tanker is 0. So from reading this context, I then realized that, oh, it is not just velocity slowing down. After 40 seconds, it actually stops, right? So in another word, if I were to sketch this out in a velocity time graph, how it will look like is that from 0, I start off with some velocity, and then after 40 minutes, basically my tanker will stop. Would this be a straight line? I do not know. Okay, but what I know is that if F net is given by MA, and that since my forward force, this F, has been cut off because the engine is turned off, then the only force that is acting on it is minus R, my drag force, my resistive force, which is in the other direction. So you can see that with this, MA is equals to minus R, and we know that this R is changing with speed. So because the tanker is slowing down, I would expect the R to be dropping. So you can see that on the left hand side, if this R is dropping, then I can conclude that my acceleration must also be dropping. So because acceleration is the gradient on a VT graph, then I can see that between this point and this point, it cannot be a straight line, because if it is a straight line, the gradient is constant. So I would expect my VT graph to look something like that. Okay, because the gradient is dropping, so it will curve this way all the way until it touches 0. And I know that the area given under this VT graph would be equals to 12 kilometer. Okay, now let's go back to your part A. So in part A, it says I need to sketch a graph, a displacement time graph, from t equals to 60 to t equals to 110. So why 110? Because 110 is this 40-minute duration that the earlier part over here talks about. Okay, so I will just take it as at the 60 minutes, my displacement is 0. It has not moved yet, right? That means I put my reference point at the time, at the position whereby the engine was cut off. Okay, so from there I will then count how much displacement has occurred. So now what happened is that I know after 40 minutes, it has traveled 12 kilometers. So at 40 minutes, I travel 12 kilometers. This is 10, 11, 12. Right? Then now I need to ask myself, okay, between the first point and the second point, is it a straight line? Is it a curve like this? Or is it a curve like that? So what we know from the previous question, so if you scroll up, when we talk about displacement time graph, we say that in a displacement time graph, the gradient is actually the velocity, right? So let's go back down. Okay, so we'll copy the same thing. I know that the gradient is actually telling me the velocity. And from the context of the question, I can see that the velocity is dropping. Velocity is dropping. This means that my gradient must be also decreasing. It must be dropping as well. So if I look at these three lines, 1, 2, 3, which one gives you a gradient that is dropping? So if I look at the center line, this one is a straight line, gradient is constant, so that is not what we want, so we do not choose this. If I look at the bottommost line, at the very beginning, you can see that the gradient is pretty flat, and then towards the end, the gradient is steep. So actually, for the bottommost line, it is showing you an increasing gradient. So I know that it doesn't match with my context. This is wrong. And that leaves us the topmost line. So the topmost line, if you compare at the beginning, it is pretty steep. And then after that, down here, it is pretty flat. So we say that this line shows you a gradient that is dropping. So now we know that the general shape is like that. We just need to draw a proper curve. So down here, you can use your curve ruler, but for me, I will do a freehand. 1, 2, right? Is it 12 kilometers? Yep, okay. So I will end here, then it will go like that. Yeah, slightly curved. It's done. Okay, then after that, you have to answer part B. How do your graph show that the velocity of the tanker is dropping? Very easy, right? We have already answered that. So as you can see down here, Cambridge only give 1 mark and it is one answer line. So they would expect a to the point answer that is direct and you do not need to over answer. Do not just write a lot, just answer to the point. So like what I said, you just need to write down, well, my graph shows that, oh, by the way, whenever you are talking graph, right, there are only two possibilities. Either you comment on the gradient or you comment on the area underneath. Yeah, so it is like a multiple choice between A and B. So even if you do not know how to answer this, right, just try to thumb either the gradient or the area. You have a 50% chance of getting it correct. Yeah, so don't be afraid to just try. So down here you can see that, where am I? Oh, okay, you just need to see that my graph shows that what? Gradient, yep, okay, shows that the gradient is decreasing. Okay, so if I just say that my graph shows that the gradient is decreasing, would I get the 1 mark? Okay, please remember that your paper is going to be sent to Cambridge and they are English speaking. So if you just say that the gradient is decreasing, they may challenge you and say that the gradient of what? Right? Even though you start off your sentence with my graph, by right, this gradient should refer to your graph. But I think it is just a good habit to always refer the gradient to what you want to refer to. So here you just add in the gradient of your displacement time graph. Okay, so there you go, you get 1 mark here. I think the question, yep, that is the end of the question. So now if you are following the video, we have gone through a total of 5 questions. So in the first question, we talk about interpreting speed time graph, describing motion. Then after that, we did again, but in a different context, we describe the motion, but this time around, we add in forces. Then after that, we talk about displacement time graph and you sketch a VT graph. And then finally, this last question, you sketch the displacement time graph. So at this point, this would give you a kind of like a quick recap on the topic of kinematics. So for now, what I want you to do is to pause the video. If you have done badly for these 5 questions, is fine. What I want you to do is that we still have 3 questions on kinematic that's remaining. I want you to now, with all these videos that you watched, I want you to try again. So in this video, you are actually being tasked to describe motion again, to sketch VT graph again, and then to sketch displacement time graph again. And while you are doing TYS, you also notice that actually the O-level keep asking similar questions. So once you master these skills, right, once you see a kinematic question, you will be able to score. Okay, so for now, please pause the video and then try the other 2 questions.